Hello and welcome to this channel. In this video, I'm going to be explaining Markovnikov rule, and I'm going to be giving you some practice problem as well to play with. And before we start, please do make sure that you subscribe to this channel and you like this video, and make sure you share to your friends as well, your department groups and other groups, so as to get in touch to other students as well. Thank you as you do. So now let's get into this. Now, addition reaction of alkene generally. Say for instance, we have alkene, this alkene over here, and you are adding a reagent AB to this alkene. Now, if you are performing an addition reaction, it's going to turn the double bond into a single bond from unsaturated into saturated. Now, we can have this C, okay, we can have this as well, where we're going to have A here and we're going to have B here. So the first A is going to join to this carbon and the B is going to join to this carbon, removing the double bond, turning it into single bond. Now there's possibility that this A will also go to the second carbon and the B will come to the first carbon. So the preference, okay, where A will preferentially go and where B will preferentially add between these two carbons is what is, is predicted by this Markovnikov rule. Now let's look at this hydrobromation of both two in. In this addition, we can have H3C, CH, and we have CH, CH3. Now, this HBr is HBr. This is going to split heterolytically. Sorry, the arrow is going to go to the bromine because it is more electronegative. Okay, and we have H plus and Br minus. Now, where is H plus going to go between these two carbon and where is Br going to go? Now, if you decide to put the hydrogen here and you put the bromine here, you have this compound. And this compound, when you check, when you name it, if you name it from here, 1, 2, when you number from here, 3, 4, this is going to give us 2-bromobutane. Now, when we place the hydrogen at the other carbon and we place the bromine also at the other carbon, say for instance, we have bromine here, we have the bromine here, and we have the hydrogen here. We're still going to have, when you number from here, okay, because you're going to number so as to give your substituent the lowest possible number. So this is going to also give us 2-bromobutane. So no matter where you put your bromine between these two carbon and your hydrogen, no matter where you put it, you get the same result. But that's not the case here in the case of this asymmetric alkene. An alkene is asymmetric when you cut it through the double bond, the two parts will not be the same. So that's an asymmetric alkene. But when you cut it through the double bond and you have two, the same parts, then that's a symmetric alkene. So for symmetric alkene, anywhere you put your hydrogen and bromine, you get the same result. But for asymmetric, if you put it anywhere, no matter where you put it, if you put it at the first carbon, the result you will get will be different when you put it at the second carbon. Let's try that. For this, we're going to have H3C, CH, CH2, okay, and also we're going to have H3C, CH, CH2. Now, when the bromine goes to the first carbon, we have this and we have hydrogen here. Now, when it goes to the second carbon, we have this and we have hydrogen here. When you name this first one, you are going to get, no matter where you start your numbering, you are going to get 2-bromobutane. Even if you start from here, you get 2-bromopropane, sorry, because this is 3 carbon. Okay, this should be higher. So this is going to be 2-bromopropane. But when you start from here, it will be 1. Okay, this is going to be 1-bromopropane. Now, in the reaction, these two products will be formed, but one will be in more abundance than the other one. Okay, one will be more abundant than the other one, and the one that will be more abundant than the other one is what Markovnikov rule is trying to predict. Markovnikov rule states that when an asymmetric reagent like HBr, another reagent that are not the same like AB, okay, when they are added to an asymmetric alkenes, the hydrogen will add to the carbon with the highest number of hydrogen. So in this case, when you look at the two carbon that is participating in the double bond, this one is having just one hydrogen and this one is having just two hydrogens. So what Markovnikov rule is talking about is that the hydrogen or the electrophilic part of the of the asymmetric reagent is going to add to the carbon with more hydrogen, okay, and the Br will add to the carbon with least hydrogen. So we expect this carbon, this product here, okay, to be in more abundance than this one according to Markovnikov rule, because the bromine is going to add to this one with least number of hydrogen and the hydrogen is going to add to this one with the highest number of hydrogen. So we expect this product 2-bromopropane to be more in the reaction than this 1-bromopropane, and this product we call it Markovnikov product, Markovnikov's product, and this is called anti-Markovnikov product or anti-Markovnikov product. So that's all about Markovnikov rule. Now let's look at some examples. Let's say we have this compound and you want to hydrobrominate this compound. You know, the two carbon participating in the double bond are this, highlighted in red, this and this. And if you look at them, this is having just one hydrogen and this is having just two hydrogens. Okay, so this carbon, should have 1, 2, 3, should have just one hydrogen. I made a mistake. Yeah, this should have just one hydrogen and this has no hydrogen. Yeah, this carbon has no hydrogen. Does it? This carbon does not have hydrogen. Yeah. So now when we look at this carbon, the two carbon, we have HBr, H plus and Br minus. So according to Markovnikov rule, the hydrogen will go to the carbon with the more hydrogen. So this carbon is having more hydrogen than this, and the end product of this reaction, the Markovnikov product, will be like this. We're going to have something like this. So this will remain the same. We have Cl, and this was having hydrogen before. Okay, now the bromine is going to add to this with the least hydrogen, and the hydrogen is going to add to this carbon now. So you might be asked to provide the name of the product form by the hydrobromination of this compound given to you. You just have to name this after you perform the addition. And if you name this, you can just try and name that. You start your numbering from A. Okay, so this is cyclohexane, and that's going to be 1-bromo, 1-chlorocyclohexane. So that's going to be the product of this, major product actually. And you might be asked for the anti-Markovnikov product as well. So for the anti-Markovnikov product, the hydrogen is going to go here and the bromine is going to come here. Now for this is having two hydrogens and this is just having one hydrogen. So where would the product go? What would be the product? So the Cl, okay, the Cl will go to the carbon, okay, with least number of hydrogen. So in this case, we should have something like this. So this is going to have 3 hydrogens. So normally they are implied hydrogen. You don't need to put them. So this is just indicating that the carbon is having 3 hydrogen. So you're going to put your chlorine here, and you're going to have 1, 2, 3, 4. That's 2-chlorobutane. Now it can happen in this kind of reaction too. For H2O, that is going to be HOH. Okay, so we have H plus and OH minus. So where will H go and where will OH go? So the two carbon participating in the double bond are this, and this one has no hydrogen, but this has just one hydrogen. So the hydrogen here will go to this carbon and the OH will come to this carbon. So at the end we have this kind of products. So we have the hydrogen here, and we also have the hydrogen, but normally you don't need to put all this hydrogen. Then we have the OH here. So normally the product should look like this. Okay, it should look like this. And if you name this, that's going to be 1, 2, 3. Okay, so we have, that is propanol. Okay, or you call it from here. If you number from here, that will be 1, 2, 3, 4. That will be 2-methyl 2-butanol. So that's going to be the end of this video. Thanks for watching. Thanks for taking your time to watch the video. I do really appreciate it. Please make sure you like the video, subscribe, and share to your friends. Your like, comments, and sharing of this video means a lot to this channel, and it's going to help us to build the channel. Thank you very much for watching. Thank you very much.